All right, guys, today we're going to look at factoring. And factoring is really just taking a sum and writing it as a product meaning multiplication. And so what we're going to really do is look at how we can divide this expression here. And so the expression we're going to look at today is 4x squared minus 32x plus 60. And so looking at the terms 4x squared, negative 32x, and 60, we want to figure out if it is divisible by anything that is the same. And so looking at the 4, the 32, and the 60, I know that they're all divisible by 2, but I also know that they're all divisible by 4. And so what I want to do is I want to start by taking out the greatest common factor, which is going to be a 4 in this case. So when I go ahead and I divide all of these pieces here by 4, I want to make sure that I account for that 4 because I want my final expression to be equivalent to the expression we started with. So we'll go ahead and we'll put a 4 out front here. And then I'm going to take each of those and I'm going to divide it by 4. So 4x squared divided by 4 is x squared. Negative 32x divided by 4 is negative 8x, and 60 divided by 4 gives me a positive 15. So just to double check, if I were to distribute this 4 into all the terms, it would give me that 4x squared minus 32x plus 60, which means I'm keeping everything equivalent. From here, what I'm going to want to do is I'm going to want to use my generic rectangle to help me factor further to get this x squared minus 8x plus 15, which is currently a sum, into a product as well. So from our work with generic rectangles in the past, we've noticed some really great patterns that happen. So I'm going to go ahead and start with my 2 by 2 generic rectangle. And I know that I can keep my x squareds together, and then I can keep my units diagonally from that. Really, you could set this up any way you want. Your x squared could go here, and then your 15 here, or your x squared could go here, and then your 15 would go diagonally from it down there. Really, it doesn't matter where they're oriented as long as they're diagonally from each other. Because what we know about generic rectangles is that the diagonals have the same product. So I know that these two empty boxes right now are going to have a product of 15x squared, because x squared times 15 gives me 15x squared. But I also know that they're going to have to sum to the negative 8x that I have here. So this is where we're going to use our diamond problem. So in the top of my diamond problem, to help me kind of solve this puzzle, I'm going to go ahead and I'm going to put the product, which is 15x squared. And then I'm going to put the sum that I'm looking for, which is the negative 8x. So I'm trying to think of two numbers that multiply to 15x squared but add to a negative 8x. If you're struggling to come up with those, write yourself a list of the factors of 15x squared, and I'm sure you'll come up with it. But what you're going to use is a negative 5x and a negative 3x will multiply to give me a positive 15x squared and will add to give me a negative 8x. That means that the two missing boxes have to be negative 5x and negative 3x, and they can go in either one. So I'll put my negative 5x down here, and I'll put my negative 3x up here. All right, now that we figured the inside of our generic rectangle out, we want to try to get to the outside. So remember, the outside is what multiplies together to get to the inside. So you can really think of this a couple ways. You can guess and check numbers that would multiply on the outside to get to the inside, or you can also look for the greatest common factor. So if I look at this first column here, I have an x squared and a negative 5x. And what I'm going to do is I'm going to look for what is their greatest common factor, what goes into both of them. And in this case, the only thing they have in common is an x. Okay, then I'll look at this next column here, negative 3x and 15, and I'll say, what is their greatest common factor? Well, in this case, it is a 3. I'll look at this first row here, x squared and negative 3x. I notice that they have an x in common. And then I look down here at the bottom, a negative 5x and a 15, and I will notice that they have a 5 in common. The thing that I want to do, though, is I want to check to make sure that the outsides are the product that'll give me the insides. So sure enough, x times x gives me x squared, so I'm good there. The problem is, though, that x times 3 does not give me a negative 3x, which means that this needs to be a minus 3 here. X times 5 does not give me negative 5x, so this also needs to be a negative 5. And then if I check here, a negative 3 and a negative 5 multiplied together will give me that 15. The generic rectangle has now helped me to see that I can further factor x squared minus 8x plus 15 as the product of the quantity x minus 3 and x minus 5. So in the long run, I'm going to write this out as the 4 that I started with times the quantity x minus 3 times the quantity x minus 5 and this is your completely factored expression. And if we were to use the distributive property, it would get me back up to that equivalent expression, which means we've done it correctly. All right, now that we've looked at that example, I want to go ahead and look at another example. And the example we're going to look at now is 6x squared minus x minus 2, and we're going to go ahead and go through those same steps of factoring that we did before. So the first thing we always want to look at is, can we divide all of the terms by something that they have in common? So looking at 6x squared minus x minus 2, I'm noticing that 6x squared and x have an x in common, but unfortunately that 2 doesn't. If I look at 6x squared and negative 2, they have a 2 in common, but unfortunately that x doesn't. So what that's telling me is that they do not have a greatest common factor, and so I get to go straight into the generic rectangle this time instead. Okay, so let's start with our generic rectangle. And remember, just like before, we're going to keep our x squareds together. So the 6x squareds will go in one of the corners, and diagonally from that, we're going to put the negative 2. Now remember, that is a negative 2 because it says minus 2. So that means that the product of our missing boxes have to be the same as the product of 6x squared and negative 2. So that means that we need to multiply to a negative 12x squared. And then we have a negative 1x, if you see up here, that we need to work with as our sum. And I'm just going to write it as a negative 1x, even though 1 doesn't need to be there. So I'm trying to think of two things that multiply to negative 12x squared, but add to a negative 1x. And that is going to be a negative 4x and a positive 3x. The negative and the positive result in a negative product. And because I have more negatives than positives, I get a negative sum as well. So I'm going to put those diagonally from each other. I'll put the negative 4x here and the 3x up here. From here, we're going to look for the greatest common factor in each of our rows and columns. So first, looking at 6x squared and negative 4x, I know that they have a 2 and an x in common. Then I can look at the next one here. If I look at 3x and negative 2, they don't have anything in common, and so we know that they can have a 1 that can divide into both of them. Looking at 6x squared and 3x, I know they have a 3x in common. And looking at negative 4x and negative 2, I know they have a negative 2 in common. And remember, now we want to check to make sure that the products of the outside give us the inside. So 2x times 3x gives me the 6x squared. 1 times 3x gives me the 3x. 2x times negative 2 gives me the negative 4x. And 1 times negative 2 gives me the negative 2. All right, now the last thing we need to do is we need to take our 6x squared minus x minus 2 and write it as a product based on what we got from our generic rectangle. So we know that this is really 2x plus 1 times the quantity 3x